Hi, in this lecture we'll be discussing about references. In our previous one, we had discussed mostly about what exactly the ownership rules are and how Rust behaves with respect to the ownership rules. Now, before I get into the definition of references, I'll try to show you an example and explain you why exactly references are useful for us when we are writing code in Rust. So let's get started with the example. Say suppose we have a variable s which is having a string as usual and it has hello inside it. Okay, now I want to calculate the length of this string. Okay, so I'll come up with a function called calculate length, and what I'll do is I'll expect a string to be uh, given into the function, and this u size will be my return types because I'm returning the size of the string, right, or the length of the string. So what I could do here is I could just write s.len in order to return the length of my string. For people who have seen the return keyword video, they could also just remove the return statement and remove the semicolon, and this function will directly return this value. But if you have not seen that, I'll make the code more explainable to you. So I'll use the return keyword. Let me save this length in the length variable here. I'll pass the string s here and I'll basically print the value here. So I'll do string length. Okay, everything looks good. I'll do a cargo run and the length of the string is 5, and that's what we expected, right? Now say suppose we have a change in requirements. We want to print the string as well, for which we are calculating the length. We'll have to adjust the print statement in that case, right? What I'll do is I'll basically print the string, which is s, and I'll print the length. I'll save it. I'll do cargo run. Now make sure you see what exactly the exception is. The exception says borrow of moved value s. Move error because s has string type s, which does not implement the copy trait. Value moved here, value borrowed after the move, which means the value was created or the variable was associated with this value here in this line number 2. The value was moved or the variable was moved in the line number 3, and it was borrowed here to print. Now if you remember the rules of ownership, when we pass this particular value inside this function, this variable will go out of scope, and when print statement wants to print this, it will not find that value because the variable has moved out of scope, and that's why we get value borrowed here after move, and we say it is totally out of scope. But how do we fix that? It's quite simple. If you want to fix it, you could just change the return type of the method to usize comma string, and I'll just return the value of s here, catch it here with a new variable s1 because this is an immutable variable, and I have to catch it with a new one. I'll print the new value of s, like the new string here. I'll clean this and do a cargo run again. We have got the value. But think about such situations. If you want to do any other operation on this string s, would you always try to return the variable s or the string value from different functions? I wouldn't do so. If I want to explain it to you, say suppose if I have function xyz later and it does something with string like this, and it is returning something of, say suppose usize again, and I want to print it. later along with the operations which we have done in XYZ. Would you return the string every time? I wouldn't do so, because this is not an efficient code. Now here comes references. What references will give you is basically a variable without ownership. In layman terms, if I want to explain it, references are basically variables or values without ownership. Now if I say here s, okay, this is more of a comment, or this is more of a understanding basis I'm writing this. If s has a reference, say k, then k is independent of the ownership rules on s. And if you pass k across this whole function, or if you want to use k across this code snippet, it becomes very easy. The value will only be dropped by the end of the code block actually. Let me show you with example. Now in this case, what I'll do is I'll send a reference inside this calculate length function, and I'll try to get the reference here as a parameter. Since I'm trying to shorten this return type to usize only, I'll use return s.len only, and then I do not need to save it as s1, or I don't need a tuple here itself. It is totally fine. What I need here is just s and the length. Now think about this. This ampersand and s is basically the reference of s, which is being passed inside calculate length. And then since the reference is already pointing towards the value, so references are basically alias, if I should say, of the same variable. Okay, the properties of the variable will remain with it, or the properties of the variable will pass on with the reference. You can still use the functions which you are using on that specific variable or that specific data type, and still you are not bound with ownership rules. Since this is taking a reference and it is returning usize, and I'm not returning any of the string types actually, I could just save length, or I could just assign it to the variable and then print it out. I did not do anything related to s, just sending a reference of s in the function and then getting an output out of it. Let's see what happens here. I will write cargo run and you see hello 5 again, which means the ownership rules have not cleared up or have not invalidated s throughout this program, and the reference of s being passed inside calculate length function works fine. Now there are two kinds of references, or two kinds of references which you could do on a specific variable. Let me list them first. The first one is immutable reference, and the second one is mutable reference. Now immutable references are those references which are drawn out of immutable variables. Mutable references are those references which are drawn out of mutable variables. Okay, this is a clear distinction. Immutable references cannot change their value because they are immutable by nature. Mutable references can change their value, which eventually result in changing of the value of the variable itself. Okay, now the key example of immutable reference is already shown in this example. This is an immutable string whose reference is passed around this function and then used here actually in order to get the length. We are just referencing an immutable variable using an immutable reference. But if you go to mutable references, it becomes a little complicated. Let me show you with an example. So if I make this variable as a mutable variable, I want to add a specific value whenever this hello string is passed across different functions. Say suppose the function which I want to use in order to add a specific keyword after hello is add underscore keyword, okay, which is basically a function which is returning addition to it, like a keyword which is added to it. So I'll use the same function to add the keyword which is world, and I'll put a semicolon here. Let's not use the return keyword because I'm just adding it and I do not want a return type. What I'll do is I'll reference it with the keyword ampersand mut string. Okay, this is because this reference which is coming inside this particular function is mutable by nature. Okay, now I'll replace it with this. Since I'm not returning any value, I'll not use this part. Now since I'm sending a mutable variable, a mutable reference inside this particular function, I'll use ampersand mute or ampersand mut as argument here. Okay, I do not need this calculate length function as well. What I'll do is I'll simply run this and let's see whether it works or not. Oh, I forgot to add a print statement. Okay, print ln. I'll just print it out in the usual way which we used to do, and then I'll do a cargo run. I forgot an exclamation mark. Okay, now you see hello world. I'll clear this and do a cargo run again. Yep, so you could see hello world. The string is being added with this particular keyword, or we have seen how exactly mutable references work in order to change the value of the string. Now there are two more concepts which I want to explain to you and which are related to mutable references. Okay, follow up with me. I'll delete this part of the code. I'll delete the function call and the print statement as well. What I'll do is, for this mutable string which we have is, let me define two more variables, and what I'll try to do, I'll try to create mutable references actually for s. Let x and let y equal to mutable reference of s. Okay, now what I'll try to do is I'll try to print both the variables x and variable y. What do you think will happen? I'll do a cargo run, and you can see the first mutable borrow occurs here, which is the declaration of x, and the second mutable borrow occurs here where exactly we declare y. The first borrow later used here, which means this particular x is used in the same line where y is used, which is wrong. What the system assumes is, before initiating another mutable variable or a mutable reference, what you need to do is you need to use the previous mutable reference before declaring it. So if I add a print ln here referencing x and reference y later, what do you think will happen? You'll find it. So if a mutable reference is not used and you come up with another mutable reference for the same variable, it will basically not work. You'll have to use the first one first and then you can reference it again. This is helpful because Rust does not want same memory allocation for two mutable references. A particular memory reference cannot be updated with two different mutable references. That's all. The second concept which I want to show you is, say for a mutable variable you have two references which are immutable by nature. Okay, and you come up with another variable or a reference variable which is mutable by nature, say z. Okay, and we save this. What we want to do is we want to print all x and y and z at the same time. What do you think will happen? I'll do a cargo run. Here you could see the immutable borrow is occurring here at x. You don't see a statement y because y is also factored in. For a mutable variable, you can have a number of immutable references, okay? But the moment you declare a mutable reference, when immutable references are already declared, you cannot reference it. You'll have to use these two immutable references before you make any changes or you make a immutable reference actually. So in that case, I'll have to use it here, x, y, and then what I'll do is I'll use z. I'll clear it here and do a cargo run. I need to add a semicolon. Yes. So in next video we'll talk about basic slices, and it'll be easier for you to understand now. I hope to see you in the next one.